All right, so why learn about drawing these Lewis diagrams or Lewis dot structures? What's the point of this? Well, it turns out that these are really helpful when we're trying to show the transfer of electrons or the sharing of electrons. So remember that when we're talking about ionic compounds, those are things that have gained or lost electrons. Okay, so that's the transfer of electrons, right? Gaining or losing electrons. As for sharing, that's different, and we're going to talk about that in the next video. So let me just make a note here. Sorry, in the next chapter, not the next video. That's all about covalent compounds in the next chapter. All right, so for now, though, let's take a look at this equation here, and we'll talk more about chemical equations in the future. But this just shows what happens when our compound, our ionic compound, NaCl, is formed. So let me kind of clean this up a little bit so we have some space. So how does NaCl, sodium chloride, right? How does that form? Well, we said in the last video that sodium likes to give up an electron because it's really close to having that octet, just needs to lose one of those electrons. And then when it does that, it's going to form a Na+, right? Sodium with a positive charge, right? Because now it's got more protons than electrons, specifically one more proton than electron, right? So for a +1 charged. When it loses that electron, chlorine over here is going to gain it because chlorine's like, oh, I really want to gain an electron. And when it does, right, chlorine is going to have a negative overall charge, right? Because now chlorine has one extra electron. One more electron than protons. One more negative charge than positive charges. And you'll notice that when we draw or write the ionic compound formula, that's what we call this. This is the formula for this ionic compound. We don't write the charges, and the reason for that is, take a look here just at these charges here. What do you notice about these charges? Yeah, they cancel out. So once these two ions are bonded together, once they formed a compound, remember they're going to stay together because they like that difference in charge. They're attracted to each other. So when we write that formula, we're not going to write any charges because they've canceled each other out, right? That's kind of why they want to bond together, is because they want to be as stable as possible, and they can achieve that stability by kind of sticking around each other. All right. Some ionic compounds, so the example we just saw above was when one thing loses an electron, another thing gains an electron. It's kind of the simplest version of an ionic compound. You've got one thing bonding with one other thing. But sometimes we have a different number of cations and anions in one single compound. And in those cases, that transfer of electrons is happening between more than one atom. So looking over here, we've got magnesium. And when we looked at the magnesium on the periodic table over here, earlier we said that, right, magnesium's in group 2A, which means it has 2 valence electrons. And it's easier, remember it wants 8, so it's easier for magnesium to lose 2 to get a 2+ charge, right, overall. So it's going to want to lose those 2 electrons, right? And when it does, there are lots of other atoms that are like, oh, I'd love to take your electron. So for instance, something like bromine. Bromine is missing just 1 electron. Remember, it's in group 7A, right there with chlorine and fluorine and iodine, right? All that are going to form a 1- charge because they want to gain 1 electron to be like the next noble gas here, right? So 2 bromines are going to bond with this 1 magnesium because each bromine wants 1 electron. And when they do that, right, magnesium's lost those 2 electrons, so it has a 2+ charge like we'd expect, right? When magnesium forms an ion, it's going to form an ion with a 2+ charge. And those bromines, remember we've got 2 of them, right? 2 bromines bonding with, right, 1 here and 1 here, bonding with 1 magnesium. Actually, let's color code that a little bit, right? So 2 bromines bonding with 1 magnesium, and each bromine is going to have a negative charge, okay? So I'm just going to represent the next bromine here because I kind of want to draw it out for you. So what I've done is I've just taken this 2 and I've shown both of my bromines, okay? So I've got 2 bromines here, each with a negative charge. What's the total for those negative charges here? Yeah, that's a 2 minus charge, right? We've got 2 negative 1 charges, and when we add those 2 together, right, we've got 2 minuses. Well, that's going to cancel out with our 2 plus charge over here. And we're going to be left with a neutral compound called magnesium bromide. Remember, we give it the ending IDE if we have that for our anions. Okay, so bromine, not magnesium bromine, right? Magnesium bromide, because we've got anions now. All right, and when we write this formula, notice that it's not just MgBr, because that would tell us that we have 1 magnesium and 1 bromine, right? There's no number here, okay? So that's just telling us we have 1 of each, if you don't see any number there. But notice we have this 2 here. Why do we have that 2 there? Well, remember, we have 2 bromines, right? 2 bromines. So we have to actually indicate that we've got those 2 bromines, or I should say bromide ions, okay? And then no number here because we've only got 1 magnesium, okay? So to recap, right, we said we've got 1 magnesium ion bonding with 2 bromide ions, and that's going to give our MgBr2, our new compound, which consists of 1 magnesium bonded to 2 bromines. And then remember, it's a neutral compound, so we don't write any charges there, right? Those charges have canceled out. All right, another thing you'll notice, besides the charges being not written in the formula, is that we always put the cation first, right? The positive ion, our cation, and then we list our anion. So cation, then anion. Anytime we name these compounds, right? You saw that with NaCl as well, right? Na is our cation, and Cl is our anion. That's just the convention. You could kind of think of it like metals are on the left of the periodic table and nonmetals are on the right. Metals are usually going to form cations, and so we'll write them first. And then nonmetals are usually going to form anions, so we'll write them second, kind of reading the periodic table left to right. So metal plus nonmetal. Cation plus anion. And let's actually color code that a little bit. We'll put the cations in yellow, and we'll put the anions in this light, we'll go with this light blue, or bright blue, I should say, for our anions. Okay. All right, and then like we said, the charge on that final compound, that ionic compound formula, okay, is always going to have a net 0 charge, right? You're not going to write charges there. That final compound doesn't have any charges because those charges have canceled out, okay? If the charges don't cancel out, that means you actually wrote the formula wrong, and we'll talk about that. Let's practice this a little bit. So this says, use Lewis diagrams to determine the formula for the following. So for the first one, let's do that one together. We're trying to create a formula, right? An ionic compound formula. For lithium and chlorine. So when those two bond together, what is their formula going to be? So lithium and chlorine are bonding together. Let me ask you this. For lithium and chlorine, which one is going to be the cation and which one's going to be an anion? Which one would we expect, and how could we figure that out? Yeah, lithium's going to be the cation, okay, just predicting, right? And chlorine is going to be the anion. Why do I know that? Well, remember, looking over at our periodic table, right? Lithium is going to be on the left side of the periodic table, And we said, okay, it's in specifically group 1A, which means it's going to want to lose, it's got one valence electron, and it's going to want to lose it, right? To be like helium over here. And when it does that, right, it's going to form a 1 plus charge. And you can even like write these above these charges on your periodic table to memorize them, okay? You can write them just like I've just done here. Okay, you can write those on your periodic table, and you're allowed to use that on quizzes. Okay, so back to what we were working on. So lithium is going to form a 1 plus ion when it forms an ion. Okay, so right, that's our cation. Chlorine over here, right, when it forms an anion, it's going to form a 1 minus charge anion. All right, so already we have a little bit of a hunch about what this compound might look like, because we know we have lithium is going to form a 1 plus charge and chlorine is going to form a 1 minus charge. So I'm already guessing, I think because those charges are canceling out, we'll probably just need to bond them in a 1-to-1 ratio for our formula, right? 1 lithium with 1 chlorine. But let's see this written out, and it wants us to draw the Lewis diagrams anyways, so let's do that. So we've got Li and Cl. And remember, lithium is in group 1A, so it's got 1 valence electron. Chlorine is in group 7A, right? So it's got 7 valence electrons. So 1, 2, 3, 4, 5, 6, and 7. All right, and already we can see, right? Chlorine wants just 1 electron. And lithium really wants to lose this electron, right? So when that happens, just like our NaCl, right? Very similar. So lithium's going to give its electron to chlorine. And what's that going to end up with for lithium? Well, lithium is going to end up with that 1 plus charge that we predicted, right? Because it's in group 1A. It's going to want to lose 1 electron, right? Now it has 1 more proton than electrons, which results in an overall positive 1 charge. And chlorine just gained an electron. Remember, electrons are negative. So chlorine has 1, 2, 3, 4, 5, 6, 7, 8. Now it has a 1 minus charge, right? Because it gained that electron here, okay? And now, in our next step, now it's our job to write the formula. So this is going to be, right, LiCl, just like that. Okay, that's our final answer, LiCl. Right, because I'm looking at these charges, and I'm thinking, well, 1 plus and a 1 minus, those cancel each other out, right? So we just need 1 lithium and 1 chloride ion, right? And they're going to bond together, and they're both going to be happy because their final compound has no charge. It's neutral. And let's actually make a note of that, sorry. Neutral. Which is kind of our goal, okay? It's more stable that way, right? To be neutral. That's why they'll kind of stick with each other. All right, so let's try the next one out. I know this is a little weird at first, but just stick with me here. So calcium and... All right, so let's take a look at this. So just like with lithium and chlorine in the first example, calcium can give one of these electrons away, right? And when it does that, it's going to give that to fluorine, and fluorine's going to be like, cool, awesome, I'm super happy now. I've got 8 valence electrons here, right? Just like chlorine in the previous example. But calcium's like, wait a minute, okay, if I lose that 1 electron, that's great, but gosh, I want it to lose 2, right? I have this other electron that needs to go somewhere. I don't want it. I want to lose 2, right? I'm in group 2A, so I want to lose 2 electrons so that I can be just like argon. So calcium's like, well, wait a minute, gosh, I want to give away this other electron. And fluorine, another fluorine atom is like, oh, calcium, I see you've got this extra electron. I would love to take that off of your hands because, you know, we've got some other fluorines hanging around. And this fluorine also wants an electron, just like that other fluorine did. So calcium's like, okay, perfect. I'm going to give you my other electron, and now we're all happy. Okay, so we've got calcium now gave away 2 electrons, right? So it's going to have what charge? Yeah, 2 plus charge, right? Electrons are negative. So if we lose 2 of them, I've now got 2 more protons than electrons. And that's going to result in an overall 2 plus charge. All right, and then for fluorine, each fluorine gained 1 electron. So we can't forget to put the electrons here, our valence electrons. So if each fluorine gained that 1 electron, it's now got more electrons than protons, specifically 1 more each. And each fluorine is going to have a 1 minus charge. Okay, but now, okay, looking at this, why did this work so well? Well, calcium's got a 2 plus charge, and now we've got 2 1 minus charges. So our total on this side of the compound has a 2 minus charge, and that's going to cancel out with our 2 plus charge. Pretty cool, pretty cool. But we can't forget to write that down when we write out our formula. So we're not going to write it like this. It's not just calcium with 1 fluorine, right? We tried that. It didn't work because calcium still had that extra electron. So you've got to let people know, hey, there's 2 fluorines here bonding with calcium. And that's what's giving you your neutral compound. Okay? What if you only had 1 fluorine? Say you didn't have this fluorine. Okay, just pretend. Would these charges cancel out? No, no. And the compound wouldn't be neutral, okay? So let's go back, though. I want to show you. I do want to keep that there. All right, so it is neutral, though. We did do our job, and this is also neutral. It's also our formula, CaF2. And then how you would say that, right, is calcium fluoride. Just like the previous one is lithium chloride, something like that. All right. Whew, last one. I know this is a lot, guys. Okay, aluminum chloride. Or sorry, aluminum and chlorine. So aluminum, we said, is it's kind of a special one. We said that it's going to form a 3 plus charge, right? So we're already kind of predicting that's going to be our cation. And then chlorine, right, we're pretty familiar with it now. We've worked with it a few times. That's going to be our 1 minus charge. So, but let's just do the diagram here. So we got aluminum and chlorine. Well, chlorine, let's do that first because we're so used to drawing that now, right? It's in group 7A, so it has 7 valence electrons. Aluminum is in group 3A, okay, 3A over here. So it's got how many valence electrons? Yeah, 3 valence electrons. 1, 2, and 3. All right. Cool. So let's go ahead and move some of these. So I'm noticing right here, we can move that electron right over here. And now chlorine's going to have the electron that it wants. But aluminum's like, wait a second. Well, that's all fine and great for you, chlorine, but I still have these 2 extra electrons I want to get rid of. So what can we do? Yeah, we can add some more chlorines. We can do that. That's legal. Okay, so here's another chlorine. Same idea, right? It's got 7 valence electrons. It's going to want to gain 1 more. Okay, so I'll put another chlorine here. 1, 2, 3, 4, 5, 6, and 7. And then look at this, right? We can give that electron there. Okay, we can give this electron here. Okay, and now everybody's happy because aluminum got rid of its 3 valence electrons. And now it's going to have a configuration that's more like neon here, right? The previous noble gas. And each chlorine is going to have those extra electrons. So, right, we've got aluminum with a 3 plus charge because we lost 3 electrons. Okay, and then chlorine, we've got 3 of them. So I'm just going to write out all 3 here. Let me actually scoot this one down a little smidge. There we go. Oops. All right, and now looking at these charges, right? Just like before, we've got 3 pluses and we've got 1, 2, and 3 minuses. And that's going to give our final compound formula of AlCl what? Yeah, 3. 1 aluminum for every 1, 2, 3 chlorines. 1 aluminum for every 3 chlorines. Right? And that is what's going to give us our neutral aluminum chloride compound.